Howdy, folks. I'm going to give people just a minute or two to trickle in. I have posted the homework per day on Katie, by the way. There will be a chain rule quiz on Friday. If you have any questions throughout lecture, do let me know as usual, and I will try to pay attention to them and answer them. All right, so our topic today is the last big derivative rule. And here what we're going to learn is we're going to learn how to take the derivative of two functions composed together. And so I want to just give you a couple examples of the sorts of functions we can't yet take the derivative of. So I cannot yet take the derivative of the square root of sine of x. As we saw in the homework and last lecture, this is in some sense a combination of square root of x and sine of x. And I know how to take the derivative of both of the pieces, but this way of combining them I don't yet know how to take care of. The same goes for something like this, where this is in some sense a combination of e to the x and tangent of x, and I know how to take the derivative of e to the x and know how to take the derivative of tangent of x, but I don't actually know how to take the derivative of e to the tangent of x. And so today we're going to change that. Okay. And in so doing, we're going to go from being able to take the derivative of a lot of stuff to being able to take the derivative of basically any function that you could ever write down. Okay. So let's start with what the chain rule says. And this should look very much in line with the notation from last lecture. Which is that if you take the derivative of f of g of x, what you're going to get is always going to be f prime of g of x times g prime of x. So to start with, let's do this square root of sine of x. Here again, this is a combination of both square root of x and sine of x. And so the first thing we have to do is effectively decompose this function, just like we did on the homework last night, and say, square root of sine of x, the inside function is sine of x, the outside function is square root of x. So this part right here is exactly what we did on last night's homework. Okay. But now we get to keep going. So now I need to take the derivative of both of these pieces. So f prime of x is 1 over twice the square root of x. And g prime of x is cosine of x. And so then our answer for this derivative is that it is f prime, which is 1 over twice the square root of x, but it's not f prime of x, it's f prime of g of x, times, and then times g prime of x. And so this will be g prime of x is cosine of x divided by twice the square root of, and then g of x was sine of x. Okay, so this function that we were not able to take the derivative of before, the square root of sine of x, we now know how to take the derivative of, and it in fact turns out that the derivative of the square root of sine of x is cosine of x divided by twice the square root of sine of x. Okay. And as you might expect, this is sort of a mashup combination of the derivative of 1 over square root of x, the derivative of square root of x, which is where this 1 over twice the square root part is coming from, and the derivative of sine of x, which is this cosine of x. The thing you might not have been expecting is that there's still the original function under the square root. That's still there. So the inside function survives inside the square root. Okay. I'm going to give you a couple minutes to look at this, ask questions if you have them about this, and then also try to do our next example. So try and set up e to the tangent of x, figure out what f is, what g is, what f prime is, what g prime is, and try and put them together just so you can get a feel for this. And as you start to do that, you might realize you have questions about what I just did, in which case ask them. And then we'll pick up in a couple minutes. Okay, so let's go through taking the derivative of e to the tangent of x. Okay, so I said this is a combination of e to the x and tangent of x. Which one is e to the x? Is f e to the x or is g e to the x? You can answer in the chat. let's see, 3 votes for F so far. And I agree with the consensus. F is e to the x, and g is tangent of x. Again, same thing we did on Friday. We just sort of broke this down and we figured out, okay, what is the inside function? What is the outside function? And so you can sort of see sort of like the most inside piece is this x. So then there's a tangent wrapped around it. So that's the inside function, which is g. And then there's an e to the x around that. That's the f. Okay. So we'll write down these derivatives. And then we know how to put them together because of the chain rule. Namely, this derivative we now say is f prime of tangent of x times g prime, times secant squared of x, which is, and so f prime in this case is e to the x, so this is e to the tangent of x times secant squared of x. Now, the way I'm laying this out on the page should remind you of the way that I laid out the product rule questions. Remember when I used to lay out product rule questions by saying, okay, so capital A is this, capital B is this. We'll take both their derivatives, and then we'll use the formula to put them together. We're doing the same thing here, except now because the inside and outside thing are really functions, I'm calling them f of x and g of x instead. And this is why I mentioned that I was going to stop writing out the product rule as lengthily, because we're going to sometimes be writing out a derivative that involves both the product rule and the chain rule. And when we do that, I want to sort of focus on the chain rule piece, because this is the new piece we have to be careful with. Okay. I'm going to just give you a couple minutes to do this question. So try and set it up exactly like we have been, and then we will come back and talk about it in a moment. Okay, so this one ends up looking very similar to the previous one, where I've combined a trig function and e to the x. Except the big difference between this one and the previous one is that here, instead of being on the outside, the e to the x is now on the inside. So when I go to write this down, now instead of f of x being e to the x, f of x here is actually secant of x, and g of x is e to the x. So f prime of x is secant of x tangent of x. G prime of x is e to the x. And so this derivative here is equal to, by the chain rule, f prime of e to the x times e to the x, which is secant of e to the x times tangent of e to the x times e to the x. That is our answer. Okay. You'll note I like to plug in the g stuff first. Plug in g and g prime. And then plug in the f prime stuff afterwards. That's just, again, so that I don't have to do all of this in my head simultaneously, which is a really easy way to end up accidentally using the wrong function when you're keeping track of this. So again, usually when I do this, I'm going to first put in g and g prime. So that's g prime, that's g prime, and then substitute the next piece. Okay. Any questions about this so far? Perhaps our most infamous homework question so far, the one I've gotten the most questions about, was taking the derivative of sine cubed of x. And so I'd like you to go ahead now and try and take the derivative of sine cubed of x with the chain rule instead of with our old way, which was to use the product rule a bunch of times. I'll give you a couple minutes again to set this down. Just try and write down the derivative of this using the chain rule. Okay, so I want to break this down into an f of x and a g of x. Okay. I definitely have to put a sine of x somewhere. Is sine of x f of x, or is sine of x g of x? One vote for G. Let's see if there are more votes. F, G, contention. I like it when there's debate. G, G, G. Okay, lots of votes for G. So the question here is, what is the inside and what's the outside? And so it's really easy when you think, okay, I'm reading from inside out, to think, okay, I see the cubed first, and then I see the sign, and that means that x cubed or whatever should be the inside function. However, that is just because of the weird notation of this sine cubed. And so in order to do this question, you have to actually remember what sine cubed means, which is that sine cubed of x is sine of x collectively cubed. And so when you remember that that's what's being represented, here sine of x is the inside piece. And then what is being done to sine of x? It's being cubed. And so our outside function here is x cubed. Okay. Does it make sense why I chose this combination in this order? Any questions? Okay, so then we write down these derivatives. Okay, and then we will go ahead and apply the chain rule. So this will be f prime of sine of x times cosine of x. And so putting sine of x now into the derivative will give us 3 times sine of x squared times cosine of x, which we would almost certainly write as 3 sine squared of x times cosine of x. And so that is our derivative. Okay, so now here's where things are going to get slightly messy. Let's take the derivative of that. Okay, I'm going to give you a minute to try it first, because anything you're going to get confused by, I want you to get confused by immediately so that I can answer it and help you figure it out. But try and see what pieces you need to put together to do this. Okay, so what's going on here? What is new in this question versus the previous question? What do we have to do in this question? Okay, so the new thing here that we're looking at is the fact that there's this multiplication here. And so this question is going to require two rules. It is going to require both the chain rule and the product rule. So I want to see what that looks like and try and do this sort of as verbosely as possible to start. And then as you practice, you'll write less and less and less. But to start with, what is this a product of? Well, this is a product of a equals 3 sine squared of x and b equals cosine of x. So if I want to use the product rule, again, remember I combine a and b and a prime and b prime. But I actually can't calculate a prime without first using the chain rule. So I am going to put a subproblem over here. And the subproblem over here is to take the derivative of 3 sine squared of x. And this is a chain rule question, where the outside function here is 3x squared. The inside function is sine of x. And so f prime of x is 6x. G prime of x is cosine of x. And so now in this world, this is the chain rule world, I get that this derivative is f prime of sine of x times cosine of x, which is 6 times sine of x times cosine of x. Okay. But this thing over here, remember, that's a. So this is a prime. Okay. So we're back to product rule world. And so now in product rule world, I know the piece of information I did not know before. Namely, I know the derivative of 3 sine squared is 6 times sine of x times cosine of x. And now I actually can completely ignore the subproblem, because now all I have to look at is the product rule, our good old friend. And so I'm going to write down now this derivative using the product rule. It's going to be a prime b, oops, plus a, which is 3 sine squared, times b prime, which is minus sine of x. And so if I simplify all of that down, that works out to be 6 times the sine of x times the cosine squared of x plus, and then what is this? Actually, it's minus, I should say, 3 sine cubed of x. And that is my final answer. Now, here's the thing to keep in mind. A lot of times people feel like I've got to learn the special rules for when there's both a product rule and a chain rule or whatever. But there are no special rules for when there's a product rule and a chain rule. We just apply the product rule where we need the product rule and the chain rule where we need the chain rule. And as long as we do that, the math will tell us everything we need to do. And so you can break this down into as many or as few pieces as you want in order to write this down, but this is how these things work together. Here is another example where it is going to require both the product rule and the chain rule. Again, practice this, and then we'll do it together. And what I'm going to do after this example is I'm going to give you some time to start the homework and ask in the chat as you get stuck on the homework or if something's not going well, just to make sure you're getting off on the right foot with the chain rule. So the hardest part to see here that you'll get used to as you do practice examples is that this example is in some sense backwards of the previous example. So this is also a product rule plus chain rule example, but in this product rule plus chain rule example, the chain rule actually comes first, whereas in the previous product rule plus chain rule question, the chain rule came second. Here's why. In our original version, I had a product of two things, and one of those two things, that one, required the chain rule. So I did the product rule because it was a product of two things, and then one of the two things I needed the chain rule to take the derivative of. Okay. Here I don't have a product of two things. Here I have a composition of two things. There's the outside, there's the inside. But the thing on the inside is going to require the product rule. Okay. So let me write that out for you. So here is our f of x and our g of x. Okay, so f prime of x is cosine of x. Okay, so far, all of this is set up exactly like any other chain rule question. But the thing I have to make sure of is I have to make sure that when I go and calculate this g prime, I don't miss the fact that this derivative requires the product rule. So I'm going to write that over here. Okay. And in the product rule land, here I have a as x squared, b is natural log of x. So a prime is 2x, b prime is 1 over x. Okay, so this is, again, product rule world over here, chain rule world over here. And so this is now a prime b, so 2x times the natural log of x, plus ab prime, so x squared times 1 over x. And so that is 2x times the natural log of x plus x. Or, as we have learned, is often useful to write it x times 2 natural log of x plus 1. I would not complain either of these ways you wrote it, but as we've seen often when we're doing a derivative, the next thing we have to do is solve an equation, and this is way nicer, the second one is way nicer for solving an equation than the first one. So we've sort of gotten in the habit that a lot of the time we write this down. But that derivative, we did that because this thing is g, so that's g prime. So g prime here is x times twice the natural log of x plus 1. Okay. And so now I put all of this together. So now I can forget about this side entirely. I'm done with that. And I just need to put together f, f prime, g, and g prime. Okay, which looks something like f prime of g of x times g prime of x. Which will be, once I realize that f prime is cosine, this will be cosine of x squared times natural log of x times x times twice the natural log of x plus 1. Okay. Now, please note, if you had written g prime this way instead of this way, then when you multiplied by g prime, that is, at this part, you would need parentheses around it, because otherwise you would only be multiplying the first part and not the second part. So this is just yet another opportunity for you to miss a parenthesis that you need. Okay. Now, there is nothing better for getting the hang of this than practice. So I am going to have you start working on the homework. And if you get stuck on any of the questions in the homework, or your answer's not matching the back of the packet or whatever, let me know in the chat, and I will happily elaborate for you, and I'll do any of the homework questions or whatever if you get stuck and want to do them. But you can start. The homework starts at. Sorry, let me look up the number. The homework starts at question 50. So start at question 50A, and then let me know as you have questions as you go through it. So the question is about 50c. So 50c asks you to take the derivative of e to the minus x So the outside function here is e to the x, and the inside function here is minus x. Good question. This can be a tricky one to spot. But this is the combination that you're looking for. Okay, 51D. Let's see. Well, let's do it and see if I get the same answer as the back of the packet. It is eminently possible that the back of the packet is wrong. It has happened before. So this is 51D. So we have h of x is cosine of x squared. So f of x is cosine of x. G of x is x squared. Prime of x is minus sine of x. G prime of x is 2x. So h prime of x is f prime of x squared times 2x, which is minus sine of x squared times 2x. Do we agree so far, Caitlin? Okay, so then it wants h prime of square root of pi over 2. Okay, so that should be minus the sine of the square root of pi over 2 squared times 2 times the square root of pi over 2. Okay. So this is minus sine of pi over 2 times 2 times the square root of pi over 2. Okay. Sine of pi over 2 is just 1, so that worked out nicely. So this is minus 2 times the square root of pi over 2. If I want to take a guess, I'm going to guess that the back simplifies it one more step than this. I haven't actually looked at the back, so you can tell me if I'm right or wrong. But I'm guessing the back next notices that this is minus 2 times the square root of pi divided by the square root of 2. So this is minus the square root of 2 times the square root of pi, or minus the square root of 2 pi. Does one of those match the back? Excellent. Yep, that was what was going on. It was just the playing with square roots. I would. I think whenever you have a 2 divided by a square root of 2, it's just much easier to realize that's a square root of 2 in the numerator. So I think this is a reasonable to expect simplification. Although I can't say whether I would give full credit for this if it was on a test or not. I'm not quite sure. But I do think this answer is definitely simpler than that one. I can do 51e. So for 51e, we have k of x is the natural log of e squared plus 2x. So our outside function, I should say first, is natural log of x. Our inside function is e squared plus 2x. So this is 1 over x. And so the key thing here to note, which is, I think, probably why someone is asking about this question, is that this e squared is a constant, so its derivative is 0. So g prime of x in this instance is just 2. Nothing more complicated than 2. Okay. If you have more questions about 51e, let me know, but I'm guessing that was probably the source of the question. For 51a, you got 5/32 instead of 5/4. Let me look at 51a. This is a 5. Okay, so m prime of x is going to be equal to f prime of g of x times g prime of x, which is 5, which is 1 over twice the square root 5x plus 1 times 5. So the thing actually wanted m prime of 3, so m prime of 3 will work out to be 5 over 2 times the square root of 16. So that is 5 over, and the square root of 16, I think you just lost the square root. Because the square root of 16 is 4. So that's 5/8. So I think you lost this square root symbol, and that's where you got your 32. All right, once I have affirmation that makes sense, I'm going to wrap up class here for today. We'll meet on Wednesday back in the classroom as usual, and we will be doing more practice with the chain rule. So definitely do the homework, get as much practice as you can, but we'll do some more practice on Wednesday just so that hopefully you can get very comfortable with using it, because it is going to be the bulk of the next test, is going to be just trig, derivatives, plus the chain rule. And so if you can really get those down, you should be in good shape for this coming test. All right, I'll wrap up there for today. Have a great afternoon, and I will see you on Wednesday. Don't forget I have office hours tomorrow, so if you have questions on the homework, feel free to drop by then.